introduction and also giving us this platform to kind of discuss some of our experience and also our point of view on how the industry is evolving and a few thoughts around that. So let me just share my screen. My screen is visible, right?
Yeah, you're good to go, Sachin.
Okay, yeah, cool. Yeah, thanks. Yeah, so, okay, and now the way we have structured this session is this the presentation that I want to cover, maybe covering the content that I wanted to put across here, maybe should be for about 45 minutes. And if time permits, we could have an interactive session. Feel free to drop in your questions and we could try to address some of that. So let me just go a little bit detail into the. So the session is titled Practical MLOps Strategies for the Computer Vision. Now, MLOps is a broad term which is applied across the artificial intelligence space. Now, when it comes to computer vision, the challenges are a little bit different. And as you go deeper into this, you realize that the problems that we have to tackle is far different, and you need different approaches to address some of those things. And a lot of people from my association, they wanted me to go a little bit deeper and cover initially what is this computer vision field, and from there bring some of this appreciation of the complexity of this field, and while there could be theoretical way of solving some of these problems, what could be some of the practical, more frugal approach to address that? For that, you require a very broad understanding, and that's what we are kind of trying to cover in this session. Okay, so let me start off with what is this computer vision. And now there's quite a bit of interpretation of this. It is evolving field, and what was computer vision 6 years ago may not be completely exactly in the state today, right? So basically, it is a sub area of artificial intelligence that enables machines to capture, process, interpret, and generate visual data. There's quite a bit of change, particularly in this angle, in this area of what you are able to generate, the kind of visual data. Either I am sure all of you would be tracking some of this new VR headsets from Apple, which has come, and these kind of Vision Pro goggles, what you are able to present to a user. So all kind of not only consuming vision and processing, but also able to generate has become a main aspect of the computer vision. And how it works, there is underneath a series of algorithms which work, machine learning, neural networks. We'll cover some of these things further, but all of this is what goes under the hood of how this entire computer vision solution actually works. And this entire field is actually transforming this entire field of digital, your ability to digitize the world and bringing that intelligence and use that for a lot of your business outcomes, and things like object detection, facial recognition, and a few things regarding smart security. These are very small use cases, but there's huge amount of use cases applied across industries and across various horizontals which is in the industry by which it is getting applied today. I will just cover one slide on on what is our product, and rest all this nothing of a flavor which is specific to us, but Squirrel Vision, which is our product from Definitive Technologies, is a specialized computer vision platform, which basically actually has three key components in that. Uh, and you will get an appreciation of this as you go in some of the subsequent slides when you look at a generic computer vision deployment. So, one of the key things about this computer vision is you sense the world at different locations, right? It could be a traffic light, it could be somewhere in your factory. So there is an element called edge within this, which with some kind of remote location, right? So one of the components of Squirrel Vision uh, is this adaptable edge kit. How can you enable a remote location to be uh, 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 your extended listener of your computer vision, right? Element. So that sensing that is what is the edge kit enables. It has cameras, it has some of this edge hardware, edge networking. All of them comes in a single package, and you can typically, as easy as in 25 to 30 minutes, roll out an edge. The next element is the flexible connectivity fabric. Now, typically, you will have some of these computer vision solution which is deployed across countries, or it could be across deployed across continents sometimes, or it could be across cities also, right? So, how does that networking happen? Some of you would have heard about terms like software-defined networks and all of those kind of stuff. How do you establish something in a very frugal way, which connects some of these edge locations to a hub or a central location? So that's where we're bringing the flexible connectivity fabric, by which you connect this edge to some location which is central, where you do a lot of some of the processing, right? So that component of ours comes as a SaaS. It's a multi-tenant SaaS hosted in various continents, where you have the edge data getting curated and passed, and the edge subsequently processes the information. I mean, the code or the SaaS element, which is the actual brain of it, processes some of this information and push it to some kind of business system. Right? So basically, this is what is the three components of Squirrel and how it interacts on one extreme, the actual physical world, and the business system at the other end. So in a sense, the Squirrel is sense, analyze, and control. So that is what Squirrel Vision provides as a value add for any of the people who are adapting computer vision, making them from an idea to market in an extremely fast way. Yeah, so that's just a few things I wanted to cover about our company, and then subsequently go back into some of the rest of the areas that I wanted to cover. Now, we've seen these layers, right? Now, let's go back and to look at some real world scenarios. Now, okay, we want to see how is this computer vision working. Now, you could visualize a scenario like this, right? You have traffic lights, and you have light, and you somehow want to have a sense of the traffic in this traffic light and intelligently control some of the signals. So typically what you would do is you will deploy some kind of cameras there. And these cameras typically capture this information and sends it to some of the different layers, right? For some of the subsequent reasoning which might be happening. So that is what a scenario that we wanted to depict here. So you have an edge location, you have a set of cameras which is streaming some kind of information. So a lot of times this information, which is raw information, which is captured from the camera, so you may not be able to use it exactly in the same form. While it might work in some scenarios, but you will have a lot of inconsistencies and all of that. So a lot of times you do kind of pre-processing, where you adjust the contrast on the fly. You might resize the image, or you might do a few cropping, define the region of interest, right? From where you want to watch the traffic, and quite a bit of those things happens in the next layer, which is typically the pre-processing layer. Now, as it goes further into the different layers of how do you process and vision, so you might subsequently, as you are observing a traffic signal, you see a lot of cars, maybe two-wheelers, and you see a lot of these kind of vehicles there. So typically, what your system is designed to kind of get features from this. So you will have artificial intelligence models, which is there. So these models have multiple layers with that, and each layer does different kind of processing, right? So some layer would extract some of these features, okay, which might be edge, color, texture, and all of that, and decide and kind of come closer to a decision that what I'm looking at could be a human, or it could be a car, it could be a two-wheeler. Now, then subsequently, once the features are detected, it's more able to kind of detect an object very clearly. So you could detect, for example, there are 40 cars here, okay, and there could be so many other kind of vehicles, right? So it's kind of more narrowed down to a very particular class of object that it has detected. Now, once that is done, then comes the subsequent layer. So the idea is again, right, entire computer vision is to sense, analyze, and control some kind of outcome. Now, it may be, for example, a safety scenario that you want to address. Now, as you get this object recognition, now let's say, for example, you were kind of want to assess some kind of threat. Maybe there is a particular number plate, right, that you wanted to kind of flag off as a warning signal, and you wanted some people to go and intercept that car or something like that. A scenario could be there. So you would have some kind of logic, decision logic, by which you determine that, okay, out of this car, okay, this particular car, you might have to take an action on that. Now you would subsequently then have a layer which you would introduce in some kind of application or logic where you might actually send a pager information or some kind of alert, maybe to the cops, right, whom you would want to go and kind of intercept them. So this is just a depiction of a use case, of a computer vision use case. So you are observing using cameras across the city, using cameras. You collect that information, you do some analysis, and as you go through the intelligence layer, subsequently you are taking action, something like this. Yeah, that's what kind of I wanted to depict here. But just for the appreciation of some of these things, how it works, and eventually our objective is to kind of appreciate the entire MLOps concept, right? We might have to give a little bit detail into this to see how some of these things actually are working. So I wanted to put this across as a very simple sequence diagram, right? What are these kind of different cameras, and how do we kind of take information from there and finally send it to a business application? So if you look at the flow here, as you trace some of these, the flow from left towards right, so you could have different kind of cameras. While if you look at the kind of cameras which is available today, by which you are able to sense, right? So you have hyperspectral cameras which look at the beyond some of the visual spectrum. You have infrared cameras. You have lidars. Then you have a lot of other high-speed cameras, which is an extremely high frame rate it captures. Uh, then you have scanning 360-degree scanning cameras. So you have a varieties of cameras which is available out there by which you can capture information. Now, how does this information capture happens from the camera? So there are cameras which you look at here directly are limited cameras. Okay, they just have a sensor and it basically streams information right upward. And he says that, okay, this is my 4K video. Please infer from this and do whatever you want, right? So in that case, you would typically have some kind of edge location, a camera streaming to an edge location. So edge would be some kind of server. It could be small gateway kind of server, or it could be really big servers, which get this video feed and does some of the subsequent processing. So you also have scenarios where your smartphone could be a camera. Let's say you have your employees on the field. You want them to capture some information and send it to the backend, which does some processing. So you would have that kind of scenario also where cameras are taking photos and sending it to some kind of cloud service. You could have timer cameras, right? These timer cameras, just for example, not of the supermarket, if you see, if you want to monitor a shelf or something like that within that, no, you need not do a 60 frames per second analysis of what is there in a shelf. Maybe 5 minutes, one shot one image every 5 minutes should be okay. So you could have a camera with a battery which will last for a month, right? Which will just keep taking images and sending to the backend. You could also have smart cameras, okay, which is AI cameras, into which you can actually load some of this inferencing code itself directly, right? Instead of having an edge. So you could have that kind of cameras also, which is doing an inferencing and saying that, okay, I have detected 40 cars here, and it directly sends it to the cloud, rather than, okay, you require doing some analysis and all of that. But similarly, if you can have all these things, smartphone, timer cameras, AI cameras, actually streaming the data to an edge. So this could happen in a scale out scenario. So let's say you have a factory with some 100 cameras. You don't want all these 100 cameras to stream data from cloud or something like that. Okay, or you don't want to a scenario where you want to have a network outage. In that case, you would actually have an edge, and you would have the data which is streaming there, and edge actually does the processing part. So it would process and determine, okay, for example, in a conveyor belt, okay, how many of these kind of packages are going, and if there is any damage in that, or if it is there's a quality deviation. So that inferencing is done here. That deviation, possibly, for example, a quality deviation, right? That is passed to a cloud. So a cloud system now does more of a business logic. Like, for example, maybe the output rate is not sufficient for a particular equipment in a conveyor belt. Or it could be, for example, a forklift is not supposed to come to this area at this point of time. So some of that information, business logic is actually implemented here, which could actually subsequently send the information to a business application. So sometimes it can be a building management system, or it could be a manufacturing automation system which is there. So you would have, and you would use protocols which is in that area, like a manufacturing, you would use something like an OPC UA, and you would send it to a SCADA or a DCS system which is there in the factory. Or you could be sending just analytics information. So a lot of times people want a visibility. So because in a business operations, there are a lot of blind spots. And that itself is an area of concern for a lot of businesses. Because as part of the digitization, so you will have information within an SAP or some other kind of MRP system, but you will see that that doesn't sometimes mirror the reality in the ground. That is the blind spot. So people want to get visibility on that. So that is where they again want continuous streaming data from some of these locations, which gets into their BI system or a data lake, and you are able to use that for a lot of analytics. Now, we looked at one part of this, right, which is how this works from a camera to doing something smart and finally going to business system, right? But how did it become smart? So a camera just streams some kind of bitmap, and how that is able to get smart is using developing some very specific application for computer vision. So if you look at here, a key part here is the brain. That how do you create the brain which is able to look at a traffic and say maybe count the number of cars or count the number of taxis versus certain other kind of vehicles. So you would have to create that model, okay, which is like the brain of your computer vision. Now that how is that created? Now quite similar to a human, right? You go through a learning process, you get trained, and subsequently maybe you become a tennis expert. So it's something very similar to that. So you train AI models for it to become smart. And lot of this training, the input for this training is data. So you using data, you provide information to the model, to the yeah. So you train uh, using some of this data, and that data subsequently gets converted into a model. Now you might in that process use a lot of libraries. So there's quite a bit of libraries which is available, which is TensorFlow, you have the Keras, you have PyTorch. So a lot of those things is used to create some of these AI models. The other important aspect in part of this training is the hyperparameters. So there's quite a bit of these hyperparameters that you kind of tune based on your requirement to get the level of smartness in the model. Now, once this brain is ready, which is able to detect some of these live real world scenarios, now you typically bundle that with an inference program. Now, there are a lot of ready-made inference program that you get, a lot of inference engine. You send that along with the configuration. So a lot of times the configuration becomes important, and these things have to be packaged together, then either deployed into a camera or an edge. Because some of the business logic, see, a lot of times we have seen that a model which performs, which looks at a car and identifies during a daytime when you have a natural light versus when it becomes darker, when you're looking at the car at a traffic intersection using artificial light, you find sometimes a drastic difference. So you might have to have that configuration of how that model either swaps the model or changes some parameter at the edge so that it kind of is able to address that. And finally, yes, all these things kind of deployed across, personalized and get deployed across these kind of different edges. So this is kind of giving that high level flow of how the development process is. Now, again, one of the goal or objective of this session is to go a little bit deeper, right, and look at and bring an appreciation of this whole process of this. One was definitely we looked at how the inferencing happens, right, how some of this detection and alerting happens. But now we can go a little bit deeper into how the development process happens and what are the complexities, so that we kind of appreciate the end goal, which is that MLOps. What are the components of MLOps and how kind of it is important. So this is peeling an onion a little bit more on this entire development process of this artificial intelligence, of this a computer vision system. Now we looked at in the last slide, the data is a very important part. Now, where do you get the data? Now, for example, if it is, for example, you want to train a model to look at taxis. Now, you might need a few 100,000 images of taxis with, with various characteristics, with various angles and different lighting conditions and quite a bit of these things, right? So the data sourcing becomes important. While you want to deploy a use case, but you need data, right? Now, there are a lot of publicly available data. There are a lot of Creative Commons contributed data. There is privately data you can source. You can generate data synthetically, okay, using using some of the AI models and all of that. But yes, so the data sourcing becomes an important aspect. Now, once you source this data, now you might have to do a quality analysis of that, because you find that a lot of data you get from internet, various sources may not be usable. You might have to discard certain data and work on a reduced set of data. So that data quality assessment and segregating some of those things actually becomes pretty important. Now, next comes the data labeling. Like what now your objective is to detect taxis versus your normal car. Now, in that scenario, you would have to label, as I told you, a few hundreds or thousands of this thing and say this is what a normal car is versus this is what is a taxi, right? So you might have to manually label that. But there are a lot of automated labeling mechanism also. This comes kind of zero short learning technology. Some of those things are coming, but still labeling is an extensive activity in the entire development process. You also have this issue of data version. So let's say, for example, you did something 6 months ago. Now you want to improve on certain KPIs, certain parameters. So you might look at a new set of data, or you might discard something further from there. So the data versioning actually becomes an important aspect. Next comes the feature engineering. Now, sometimes you work directly at the data level, or sometimes you work at the feature level. Like, for example, car has four wheels. Okay, you could take some of those things and kind of take it to a higher order for inferencing. So you might do some of those feature engineering and all of that. Now, then comes the core work on the model, that AI model, which I was mentioning, TensorFlow, Keras, and some of this model. So there, where you start training this model with this data, with all the hyperparameters which I was mentioning. So it's a repetitive task, and some of these things can be extremely intensive in terms of compute resource. So these things run on some of the GPUs or some of the tensor processor architectures, and some of these trains we have even run for weeks together to get a good kind of model. So that is a circle. So you test out a model, you kind of evaluate that against the various KPIs. We call this as experiments, right? You keep doing these experiments, and suddenly at one point of time, you have a satisfactory model, and that you kind of are able to take it forward. Now, going from that, let's say yes, you have this kind of satisfactory model that you have developed. Now you have decided, okay, let's now take it and push it to the field. Now comes the next set of stage where you package and deploy this model. Now, if you actually look at, yes, so we have 1, 2, 3, 4 version, you decided, okay, version 2 is what I'm going to roll out. Now, then subsequently, as I was mentioning before, there may be application components. Like, for example, as I was mentioning, during nighttime, there is one model, daytime, there is one model, or based on the first level inferencing, you kind of determine, put it into different buckets and quite a bit of stuff. So there may be an application component which gets bundled along with the model. So you have a CI/CD pipeline by which you subsequently do that application modification part and then take it to the deployment part. Now, once a model goes to a deployment, then you might have to be very careful because it depends on the business criticality, right? Like, for example, if you are changing something on a conveyor belt in a factory, now that has to be very, very carefully managed. Now, how do you do that? Or it could be in case of a traffic signal, right? Now, like, for example, you had a model which was detecting, for example, a public transport bus, and your the local bus transport company decided to change the color of the bus, right, from green to pink. Now suddenly your model can start misbehaving. So you have releasing a new model for that. Now, how do you do this A/B testing? So if you have, for example, 100 cameras across the city or in one particular highway, so how do you change it in certain part of one highway and test it out for a few hours or a few days and change the rest of the work, right? So that A/B testing and rolling out and scaling the hardware actually becomes also an important part in the deployment. Uh, as I was mentioning, some of these are extremely compute hungry, not only during the training process, it can also be hungry in the inferencing process. Because you have, again, a simple object detection, you have more complex classification, or you have today image segmentation. And when some of these things runs, these are extremely expensive in terms of compute. So even the compute, you might end up having a GPU grid, which is kind of able to take this video stream or images and do the processing and send out the data, right? So that the hardware scaling becomes an important part of that deployment. Now, all good. So the model is deployed and it is up and running. Now that doesn't stop us to kind of log off from there. Now you have the scenario where the teams have to start monitoring this, right? Because you can have scenarios where a model can drift. And scenarios is like what I explained before, where the transport companies suddenly decided to change the color of the bus, right? And what was supposed to be detected in some way is detecting in some other way. So the models have to be continuously monitored to see that if there are deviations from that. Now there are tools to do that. You could write inject scripts to do that. There's quite a bit of those things which happens. And based on that, if you find a need to retrain that model, recreate that brain again, that is where you might have to initiate that process of retraining. Some of those things again can be an automated pipeline by which it gets retrained. And once that is retrained, it gets again deployed back at that location. Well, all good, but as usual, some of the software deployment lifecycle challenges again comes here. You might have to have a scenario where something has gone wrong, right? You have decided that you have to roll back. Now, how do you roll back? So you can have 10,000 traffic signals, right, where you have deployed your model and this thing. So that rollback model mechanism sometimes become extremely critical in some of these scenarios. So this should, from the previous slide to this slide, should give you a little bit of detail, a little bit of appreciation of this system for you to kind of get to the next level and understand how to kind of visualize if you decide to deploy a computer vision system. So how can that be conceptualized and deployed by you? Now, looking at the previous slide, a little bit of appreciation from a data perspective and how that ties into this whole process is an aspect which is getting discussed very particularly from a computer vision perspective. While this is universally applicable across, but it is little bit more crucial from a computer vision perspective because the data is voluminous. Because the amount of data which is required for training, certain data you might have to retain for compliance and all those things. So this terminology called data flywheel, which is getting popularized, is basically a concept of, okay, how this, you from a development process, how do you apply that model into a production or into a camera system? Observe what is happening there at every stage, okay, or every inferencing. You just observe to see that if there are any deviation from that, collect the data back from them. Like, for example, in the scenario of the transport buses that we were talking about. So you might sample, for example, one image every 1,000 buses that you are seeing and send it back or keep it for an archival. You feed that data back into your data repository. So your data kind of grows and you use that for development. So it is like a flywheel, which kind of with its own momentum, it keeps running and making the things more smarter and smarter. And if, from the so so from that entire flywheel perspective, so the key layer, if you look at from a data perspective, that is how once the data comes back, now you might still want to inspect that data. You might want to algorithmically transform. You might have to do some metadata enhancement around that. You might have very specific additional capturing from the field. You might auto label, or you might also introduce humans in the loop to do a reinforced learning from the human feedback into this. So this kind of is a terminology which is getting popular more from a data perspective, but but this data being one of the biggest challenges of in the field of computer vision. Okay, I thought it's good to kind of give an appreciation of this so that you kind of are able to build the thought further on it. Now, we fairly got an idea about how some of these things works under the hood, both from a inference perspective and also from how some of the development happens. Now, some of the challenges that while we touched upon the data part in the previous slide is with respect to the need for more and more data. Like the amount of data, for example, you have different traffic conditions when you look out, or you have different weathers, for example, rainy condition, fog, or you have other dusty environment and all of that. So if you want to generalize your model to kind of be tolerant to some of those things, then you need that higher dimension level of intelligence. Okay, which means more and more data, which is required to tune some of those things, right? So the more data is sometimes more smart to hear. So that data is one of the biggest challenge which is there in the computer vision space. So the next one is some of the points that we discussed, right? So you could have environmental scenario, okay, which you're just not able to tackle at the model or the data level, but you might have to have some other logic by which you are able to determine that this condition has occurred, so I'm going to do this. Like if, for example, light has gone out, then you might have some other mechanism of detecting things even without a camera, right? So you would want some other sensor to be activated. So that kind of scenarios we kind of encounter very often in very critical deployments. So the other one is contextual and cultural understanding. Now, this aspect is also very important, and this sometimes is one of the issue related to the trust, which is there, or the bias some of these models show. See, because as I was mentioning, if you look at the different parts of the globe which contributes data, if you look at the west versus east, so some of the amount of data which some of these models are trained, the source of this data is more from the US, from the Europe, and some of these areas, and maybe some part of the East. But in certain countries, the data contribution is less. So if your model's ability to understand or associate to that culture sometimes becomes less. Now, some of the scenarios, for example, okay, you would want to determine the age of a person by looking at that image. Now, that determining the age of a person just by looking at the face of a person is based on the data, right? So it's the number of, for example, an Asian face the model would have seen versus some of the from faces in the other geo, right? There will be significant difference. So the error of uh, judging some of the face emotions or age can change across locations. You could also have scenarios. For example, in some countries, the cars or the vehicles are driven on the left side of the lane. Okay, somewhere it is on the right side of the road, right? So, in case you want to detect if someone is doing a traffic violation, so you need that contextual understanding. So you need that entire application to kind of adapt to that scenario. So that is a big challenge in some of this computer vision solution. So the next one is the generalization of the domain, right? So why, for example, you want to have a detect people in uniform, right? So you will find that so you to generalize something like that. So you would have to have that so much of data, right? Because a uniform uh, for a cop may be different in one country versus another country. So you would have to have that kind of domain if you want to have a model which can adapt to domain. So you would need to have that kind of generalization, which is again a big challenge in the industry. So the next is also an important aspect of security, privacy, and some of the ethical concerns. Now, one of the issues is okay. Now we are capturing information from cameras, so which means you would capture face of people, right? You would capture various other characteristics. Now, there are countries which doesn't allow that because you are not allowed to personalize. Even we have encountered situation where employees, okay, there are union rules where you cannot monitor them at an individual level. So you might not be able to capture face. You might have to have mechanism of taking that out, or you monitor in some visual spectrum which doesn't monitor where you cannot identify people by individual. You also have some of these hacking techniques by which you can hack a vision model. So, like for example, you could wear some certain kind of a t-shirt pattern and go front of a camera, and the camera may detect you as a horse, or it can detect you as a non-human, right? So there are ways of hacking because the way some of this convolutional neural network works, it kind of converts these pixels and there are multiple layers it goes. So you could have a scenario where you are able to hack a model by using some of these techniques, okay, what we call the adversarial attacks. So there has to be risk mitigation approach to those kind of stuff also. And these are becoming concerns nowadays. The other aspect which I mentioned again was regarding the resource constraint, and particularly at the edge. And if you want to run a GPU and some of these high power clusters at the end, and especially in a mission critical way, the amount of energy it consumes is a lot. And you might also, because of some of these computing speeds, even a small brownout in a traffic in the power for a few milliseconds can actually bring down cameras and reboot. so which can be extremely dangerous. You and some of the times you will not be able to have put a UPS, expensive UPS at every edge location, right? So that resource constraint at edge is always a challenge. So the next one is the explainability. So how are you able to explain? See, in a traditional application development, so you could look at a code, you could look at the if next statement, use and go through the case statement and say, okay, this is the how the logic flowed, and this is the result it produced. But unfortunately, in some of these new age, the neural networks or some of these transformer models, okay, it is extremely difficult to do that level of traceability to find out that this is the reason why this model took this decision, right? So most of this are like a black box, right? You send something, it produces some output. Uh, so that is a challenge. Well, there are ways of mitigating some of those, but it is definitely a big challenge which is there. Integration and scalability issues I mentioned before, because there are varieties of cameras, which I touched upon in the very second slide. And these cameras are different kind of interfaces, and based on the performance, speed, and all of that. Okay, so how do you tackle some of those things? That is an important aspect. Adaptive and continuous learning, as I was again mentioning a few scenarios where you have to continuously get the data back and use that to train and push the model back, just like what we saw in the data flywheel slide. Then finally, it is the technology and methodology innovation. The speed at which some of these artificial intelligence development is happening today, the new algorithms which is coming, some of the new hardware, like for example, the new neuromorphic processors, which is going to come in the next version of your uh, Intel core processors, core generation 14. So can help you to do very efficient neural processing. Now, if you want to integrate some of those things, how flexible are you? Then again, some of these vision transformers which is coming, which is kind of state of the art reasoning it is able to produce, zero shot learning. So you need to be able to quickly adapt to some of those things, and that becomes a critical aspect of some of these deployments. Now, so we initially started off with quite a bit of learning, getting an idea about how some of these things work. Then subsequently, some of the challenges which is there in this field, how to tackle some of those things. But we're not leaving with that. We just want to subsequently look at some of solution options which is there. So when you look at from an MLOps perspective, that is, you are a team within an organization, you are running a mission critical computer vision solution in your enterprise. So what are the tools that you can consider? So you will find a plethora of tools here. So it is not necessary that all these things have to be implemented. Now you can start off a solution which is purely manual, right? You design scripts, you design your own orchestration logic and all of that, and you could have a completely a manual system which is doing all these things, right? You might want to automate certain areas. You find there are low-hanging fruits that you can automate, and you would want to write some automated scripts or pick and choose a few tools from here that you feel as bang for the buck. You might want to take that and implement a semi-automated solution. Or you can pick all these things, right, and integrate together and create fully automated solution. Now, all depends on the return on investment, how much dollars is there to invest, and how does this pay back, and it's based on that. So you might have to pick and choose all these models. So I'll quickly run through some of these things so that at a point of time, yes, if you want to take a decision, you could look up further in some of these areas. The very first one is the data and pipeline versioning, just like your Git. So your Git cannot handle so much of data, right? We are talking about terabyte and petabyte of data in a computer vision solution sometimes. So the data versioning and some of those things actually becomes important. So you see a plethora of tools here, right? Like the DVC and GitHub, Git LFS and all of that you could actually adapt for the data versioning part. So the next one is some of the version tracking, because as you develop one version, different version, the hyperparameter changes. There are so many things changes. In the amount of tuning cycles, the PNR value, so your weights are different. So some of those things, right? You want to have some of those experiments tracked with the hyperparameter which went into creating that model. So you might have to have an extensive repository of that. The next comes the workflow, right? So how do you both the training process and the inference process, right? So how do you, when a data scientist is actually training a model, so how does it actually pull data from somewhere, stage it somewhere, create an image, put it into something like a cube flow, and run the GPU code in that, and it would run for maybe 6 days and give you the result. So you need that kind of workflow orchestration where you don't want someone spending time and looking at eyeball, looking at some of those things. And there are simple options also. You could actually use even Google Colab for training if it is a small kind of use case. Yeah, so there's quite a bit of options there. Some of the next machine learning frameworks we touched upon, like the TensorFlow, PyTorch, and even some of the OpenCV, and some of those models are extensively used for some of this kind of machine learning frameworks. We also discussed the data labeling, which is a critical part. So how do you label thousands of these images and say this is a taxi, right? So you would have some of these labeling tools. Some are available on cloud. Some of them you can deploy, and you can do some of those things. Some of the traditional tools where you might sometimes have to categorize and look at some of the data exploration in a more typical way, create a Gantt chart, or create a bar graph, and all those things and visualize. You need, again, big repositories into which you are able to connect some of these tools and get the kind of data. The feature stores, we discussed some of the features. In computer vision, it could be color, it could be edges, it could be quite a few of these kind of features. But some of these things can be universal. Okay, even in kind of, for example, a recommendation system, you could have a different kind of features which is used there. So some of these things can sometimes become more common across an enterprise. Model development and serving. So how do you create some of those models, and again, in a extremely, if you want to scale, for example, in NVIDIA Triton inference servers, right? You might have to put some of those servers in a factory so that it is able to kind of process that thousands of frames per second kind of speed with multiple cameras injecting images and all of that. So that becomes an important part of that MLOps area. And some of the cloud and infrastructure anyway becomes a critical part when there is a cloud element, and you want to push some of this training code and all of that and have it in a Kubernetes, which could be subsequently used by a Kubeflow to run some of the workload. CI/CD, both from an application which conjoins a model, or even for the model. So you could have a lifecycle management for that using some of those traditional DevOps tools, which is there for some of those things, triggering events and some of the automation. Why we spoke about some of these point tools, there are some of those tools which comes bundled with quite a bit of these things, which is from the hyperscalers, right? You could go to the hyperscalers cloud platform. You could create an account there and do quite a bit of stuff integrating their services. There are pluses and minuses of that, because a lot of times the pain area of a computer vision solution is outside some of these cloud. It could be in factories, it could be in traffic signals, it could be some of these remote locations which spits out so much data, and you have to have the model managed there, and all of that kind of stuff which is happening there. Yeah, then some of that MLOps, okay, specific tools which is available, which addresses certain aspects of the MLOps, specifically for the deep learning areas. So you have some of those things. Then you have some of the model monitoring. Okay, so how some of the KPIs are performing. Okay, like for example, it is supposed to deliver so much of inferencing per second. Okay, so how do you kind of continuously monitor that? Collaboration and versioning becomes an important aspect of how some of these things are exchanged across, so that a collaborative team across the world is able to work on some of those things. So one more other aspect is the model governance and compliance. Now, as you start putting new models, okay, how do you deploy some of those things, and how do you monitor some of these KPIs, and including some of those internals, like for example, the traceability aspect. While we say that neural networks are a black box, but as you look at the layers of the neural networks, you could kind of have an explainability, saying that at this layer, this feature kind of it combines with these features, and it kind of determined a particular class, right? So some of that traceability aspect of the bias, and some of those pathways of how we took a decision to some extent can be tackled by some of these tools. So some of those things are there. And finally, you might have solutions, right? You might have deployments where it is a drug discovery scenarios, where some of these very confidential informations are kind of visually analyzed and looked at. So you might have to have a different processing technology which can happen in a non interpretable way, where you use some of this homomorphic encryption kind of stuff, where you do compute uh, in that, and then produce the result and take it, or the result which is produced, how do you categorize and send it for some of the other application process. So you could look at different areas of how this could be employed. So this was my last slide. So the idea was, yes, to how do I, in a very kind of 45 minutes, maybe I just overshot it by 5 minutes, uh, to kind of give you an idea about give you an idea about this entire field, and bring an appreciation about some of these tools are there. It is getting discussed, and if you're looking for a computer vision solution, how you can look at some of these solutions to as you determine some of your solution.
Fantastic, Saji. This is Ravichandran. I think this is a very, first of all, on behalf of AiThoughts.org, I want to thank you for taking time out. I know you are running a startup, so there is no time. And so that any time you take it out is valuable for you. And so thanks a lot. And I think that absolutely kind of terrific kind of encapsulation of this whole process. And then basically your experience working with clients and actually deploying solution comes out. And kind of few things for others is because right now there is a general feeling, there are two questions, and then see if you can answer them. One is with the large language models, multimodal. When they say multimodal, it can take care of audio, video, etc. And people are saying, people may be thinking wrongly that they don't have to do anything. Okay, they can create a factory-based, a kind of warehouse-based, just deploy cameras in the warehouse and start using the multimodal, your llama, and then the system will work. I know that obviously enterprise solution don't happen like that. And I just wanted you to explain to people that you still have to worry about that all the generalized data is good, but your factory data, your product data, your warehouse data, and if you're looking at smart solutions, the traffic solutions you talked about, smart buildings, smart traffic light system, and smart water management, smart power, and I think so much of importance on your domain data. And so while it's going to improve, that it is not going to be because these new language multimodal models have come, we can do it in basically much differently than what you've been doing. And the second thing is, what are your suggestions? Because data labeling has always been a kind of most tedious task. And so the self-supervised learning, a lot of new ideas have come to say how the labeling itself can be automated to a large extent, and then keep the human kind of input basically to the minimum. And so I think it's because right now the people are all saying, I don't need to label. So this is another misconception because of the LMLs. For the last, I talk to people and say, Ravi, what you used to teach us 2 years back is no longer true after ChatGPT. I tell them, no, for enterprises, you still have to, and that is what Andrew Ng is also saying that for the next few years, your supervised learning with data labeling is going to be 80, 85, 90% of the AI solution. And this unsupervised learning, etc., is going to take slowly to take time. And so if you can add some of your thoughts on that, that would be good.
Yeah, sure, Ravi. And Ravi, thanks for some of the kind words. Yeah, we are definitely a startup, and it's good and bad. Okay, while as you said, we definitely every hour or every minute of us is kind of critical. But again, some of the other things is we don't have a baggage. Like for example, when you mentioned about some of the large language model. So virtually we have tried Gemini, we have tried GPT Vision 4, and some of those things we have integrated. It is purely based on the use case. Now, you would have use cases where you could adopt a GPT-4 vision, right? And you are able to just take a photo and of a road, and it says that yeah, there is so many people standing here, and it says that this uh, bus is from so and so provider. Maybe okay, it doesn't do to that level accuracy, but it does that. Now, you might have a scenario where you could actually use that, but now where are you applying that for? Like, for example, in a factory, right? If you have to use something like a GPT-4, you're looking at a conveyor belt. So in a conveyor belt, there are equipments which is moving, right? Now, in a GPT-4 vision, if you want to use, you have to take the photo of one of the snaps from a conveyor belt. You have to send it on an API call, which goes to one of the nearest data centers of OpenAI, gets the result back, and comes back. And some of these things, times we have seen it is even 4 to 5 seconds for one response to come back. Now, by the time, so today, typically some of the edge deployment which happens in a factory goes up to 30 to 60 frames per second. That is the speed at which you capture information, right? So there is no way you can send it somewhere far off and bring it back. So that is one challenge by which you might have to exclude some of those kind of scenarios. But you might have a scenario where, for example, okay, you have in fact, some of the areas where this performs well, let's say, for example, you have a complex flow chart. So you just take a photo in ChatGPT 4 and tell him to interpret this and explain. Now, he does that in a phenomenal way. Okay, so that is because of that emergent knowledge it gained using the multimodal, right? It trained on so much of data, so much of video, so much of images it has looked, and using that, it is able to interpret that in a phenomenal way. So, and if there is a scenario that you would want to use that, you should definitely use that. But the use case is the one which should drive what you want to take and apply. And Ravi, since you mentioned that large language model, so the application of large language model is still broader, right? One is definitely a multi-model where the vision aspect, since the topic today was vision, but even beyond that. So when you look at how do you leverage some of these large language model, of course, the prompting. Prompting is one of the biggest opportunity, right? Where single shot, you prompt, it does something for you and you get a result back. So the prompt engineering becomes a very important thing. You use that to leverage some of this, what you get output from a large language model. Now, the next one is tuning. Now large language model, yes, some of those the tuning challenges, the amount of data this has. So you cannot tune some of these big models, right? You might have to tune based on the amount of dollars you have some of the lower models, so that you give that in context knowledge to that. Now, yes, so you can tune that, but it is not easy because the way the model will break the quality of data, all those stuff that we saw before in that data part becomes a critical part, and you might spend 1 month training a model and seeing that the model is not performing. Okay, so you would have that kind of challenge if you try to take and tune some of those models. But the other one is to also use some kind of retrieval augmented generation, where you have a vector database kind of in the middle, where you kind of take out the data context from the vector database based on a query which is coming, send it to the LLM. Okay, and that API could return back an information, and then you subsequently take it forward. Yes. So to answer your question, Ravi, yes, it purely has to be a use case driven. We are not in this school of thought that it has to be something homegrown, your own edge, and all those things. Then they're on the other extreme that yeah, something I get free, or not free at least. Okay, I just put a prompt and I'm able to get an answer. Yeah, hopefully, Ravi, I answered your question.
Yeah, very good. Thank you. Yeah. Divakar.
Hi, Saji. This is Yashwant.
Yeah, hi.
I have one question. In the imaging area, the camera applications and video applications in which you work, you mentioned that you take any use case. In that use case, the amount of data which is required, for example, traffic signal, you require thousands of images of cars and buses, etc. And then you discard many of them. In the LLM space, in other areas, they the experts have been talking about augmenting the real data using a synthetic data which is created again by the AI model. So is that kind of in an LLM which is textual information mostly, is that kind of thought process applicable for the imaging areas also, or imaging area applications do require real data and synthetic data is not useful?
Yes. So now typically in one of that diagram which I was showing, so that is an important part. So let's say, for example, in the traffic scenario that you mentioned, so you have an image of 100 cars, right? Now, one of the things that we do in that pipeline is the data amplification or augmentation, right? So one car, we can actually make it into 50 cars, right? By uh, by left and right flipping the image, right? Or you could turn it by 20 degrees, or you could add a noise into that. You could stretch it. Okay, so that same image of one image of a truck or a car becomes 50 image by using some of these things. So you have that kind of simple amplification technique which happens by which and which is part of most of the pipeline which happens for machine learning. Now you will have a scenario where you don't even have that. Now you would want synthetic data purely. Now, not exactly a language model, but it can be connected using some of the diffusion models. So today, if you look at how some of these synthetic images are generated of people, right? You can go to Bing and say that please give me a photo of God Krishna, right? It will give you an image,
Correct.
right? So you could have that kind of synthetic data which is getting generated and which is using what we call the style GAN. You can do a little bit of transformation, diffusion model. But yes, you could significantly amplify that image. But yes, you will have to monitor that carefully. What is that final model which is coming out? It is delivering to your business KPI. Okay, that is the ultimate test. Yeah. So answer is yes, you can do all those things, but it has to test that in the business use case.
Thank you. Thank you very much.
Yes, Shaji. Thank you. This is my stepping stones for AI and ML. So this session was very informative. Thanks so much for taking this. It's very useful.
Yeah, thanks, Anish. Thanks for that.
Thanks, Ajay. Divakar here. Thanks a lot. I don't know, any more questions from anybody? Raise your hands and make you just speak in. All right. If nothing more, then Saji, thanks a lot. Really appreciate the time that you've taken for the session, the efforts you put in. Much, much, much appreciated. For those who want to see the recording of this, we'll be uploading that shortly on the YouTube channels. Thanks again, Saji.